So this is installment number 3 of your logarithmic review. If you watch the previous two, the first one I mentioned to you that there are certain properties of logarithms that have to hold true because of their relation to their exponential properties. I'm going to spare you the proofs, but we're going to look at the 4 definitions that I want you to remember and be able to apply. So this first one up here is the logarithm of a product. We call this the product property of logarithms. So when you see a product inside of the parentheses being inputted into the logarithm, we can then write this property as the logarithm of r added to the logarithm of t. So it's very subtle there, but this multiplication, this product, becomes the sum of each of the logarithms of the factors. Logarithm of r times t is the log of the first factor plus the log of the second factor. Make t a little more obvious here. That's the product property. In the second one, I have a quotient. Fancy word for division, correct? So r divided by t, the quotient turns into logarithm of r minus, or subtract the logarithm of t, right? So again, we have this quotient that translates into subtraction. There is a tie-in very easily to the quotient of powers being the subtraction of their powers of like bases, or the product of like bases is the addition of their powers. Since the logarithms are talking about powers, it makes sense that these turn into addition and subtraction. Keep that connection true for both logarithms and exponents. For this one, the logarithm of r raised to the t power, that t is in superscript, right? What happens is this t then can come and drop down out front. So this becomes t times the logarithm of r. And lastly, with this one, the logarithm of 1 over r. Well, you might think, isn't that similar to this problem? Now, I'll show you the connection in a second. But if I think of 1 over r, the result is supposed to be a negative logarithm of r. Now, let's go ahead and use that thought I mentioned about how it looks like a quotient. Well, if I write this using the quotient property, this would become the log of 1 minus the log of r. It's subtle, but log of 1 is actually 0. Why is that? Remember that the logarithm asks the question, what power of 10 is this number? 10 raised to the 0 power is equal to 1. Therefore, the log of 1 has to equal 0. So log of 1 minus log of r simply becomes 0 minus the log of r, or, as the property shows, negative log of r. And we call this the reciprocal property of logarithms. As you see, it's the reciprocal of r.